How does covariance relate to correlation in Python? Imagine you're trying to understand how two things change together. Maybe you're looking at how the temperature affects ice cream sales or how study time impacts exam scores. Both covariance and correlation help us measure this relationship, but they do it in different ways. Covariance tells us if two variables tend to increase or decrease together. If both go up at the same time, the covariance is positive. If one goes up while the other goes down, it's negative. But here's the catch. Covariance depends on the units of measurement. If you measure temperature in Celsius or Fahrenheit, or sales in dollars or thousands of dollars, the covariance values change. This makes it tricky to compare relationships across different pairs of variables. That's where correlation comes in. Correlation takes the covariance and adjusts it by dividing it by the product of the standard deviations of the two variables. Standard deviation is a measure of how spread out the data is. By doing this, correlation scales the measure between -1 and +1. A correlation of 1 means a perfect positive linear relationship, -1 means a perfect negative linear relationship, and 0 means no linear relationship at all. In Python, calculating these measures is straightforward. You can use the Pandas library, which has built-in methods. For example, if you have a data frame with your data, calling gives you the covariance matrix, showing how each pair of variables covaries. Similarly, corr gives the correlation matrix, showing the strength and direction of relationships on a scale from -1 to +1. These tools make it easy to analyze data and understand how variables relate to each other. Understanding the link between covariance and correlation is essential because it helps you interpret data more clearly. Covariance shows the direction of the relationship, but because it depends on units, it's hard to compare across different data sets. Correlation standardizes this, making it easier to see how strong the relationship really is, regardless of the units used. For example, if you're analyzing sales data and temperature data, converting covariance to correlation allows you to compare how strongly temperature influences sales without worrying about the units. You can also use correlation matrices to see all relationships at once, which is very useful before building models or making decisions based on data. In time series analysis, you might look at rolling covariance and correlation to see how relationships change over time. This can reveal patterns or shifts in data that static measures might miss. So, in simple terms, covariance measures how two variables move together, but it's scale-dependent. Correlation takes that measure and puts it on a standard scale, making it easier to compare and interpret. Python's tools make calculating both quick and simple, giving you powerful ways to analyze data relationships effectively.